So now let's look at an example about how we identify minerals and actually test using some of the properties here. Here we have 4 completely different minerals. 3 of them look very similar, but these 3 have this sort of blocky behavior, whereas this one has a more massive behavior. But what other diagnostic properties are there that we could use to discern between these 3 minerals if we know their color is different, or these 3 minerals because we know that they have a blocky habit? So let's look at an example about how we actually do that in the first place. So we're going to look at this mineral right here, which is mineral number 18 in your rock and mineral box. Now remember, there are a few properties that we can use to help identify minerals. Those include its luster, its hardness, its streak, and its breakage, so whether or not it cleaves or fractures. The first one that we can use, because there are less categories than the other, would first be luster. So now we know that we have 2 types of luster, non-metallic and metallic luster. Now remember, luster is how light interacts with the surface of the mineral. So if light were to readily reflect and refract off the surface of the mineral like a metal, it would be considered to be of metallic luster. As we can see, light goes right through this mineral, which means that it is a non-metallic luster. Specifically, it is a vitreous, so glassy type of non-metallic luster. But there are still many other minerals that also have non-metallic luster, just like these other few minerals we have here. So what is another type of property that we can use to help discern this mineral? The next one we could use is hardness. So that's essentially a mineral's resistance to scratching. Now remember, we have a couple different common tools that we can use to help determine hardness. Those include a nail, a penny, a streak plate, and your fingernail. So now remember, when I like to test for hardness, I always like to start with the hardest tool. So that would be the nail here. So this nail here has a hardness of 5 to 5.5. So what I'll first do is I'll take this nail and I'll scratch it on the surface of the mineral. And as you can see, the nail has scratched the surface of the mineral and powdered it. So I know that this mineral is not harder than 5 to 5.5. It is softer than 5 to 5.5. So what is the next kind of implement we can use? Because we know, even though it's softer than 5 to 5.5, that means it could be a hardness of 4, a 3, or 2, or a 1. So now let's use the penny. And so we'll take the penny and we'll scratch the surface of the mineral. And just like the nail, it has powdered the surface of the mineral. So now we know it is softer than 3 to 3.5. So the next tool we can use is our fingernail, which is the easiest one. So again, I'll just take my fingernail and try to scratch the surface of the mineral. Now, unlike the penny and the nail, my fingernail has not scratched the surface of the mineral, which means that the hardness of this mineral is somewhere between 2.5 and 3, because my fingernail is somewhere between 2.5 and 2. But we know it's softer than a penny, which is 3.5 to 3. So that means the hardness of this mineral is somewhere between 3 and 2.5. What about the next type of property that we can use? Well, now we can look at fracture and cleavage. So how this mineral breaks. So remember, the difference between fracture and cleavage is whether or not it breaks along smooth, parallel surfaces, or whether it breaks on irregular surfaces. So how I like to identify cleavage and fracture planes is first by seeing if I see any smooth surfaces. Now this mineral is nice because all the surfaces are very smooth. Now remember, cleavage can be in many different directions. So this mineral is in a cube prism-like shape, which means that this surface right here is parallel to this surface. This surface is parallel to this surface, and this surface is parallel to this surface. So this mineral, if it were to have cleavage, it could have a maximum of 3 directions of cleavage. 1 direction, 2 directions, and 3 directions. So first I like to see whether or not I see any characteristics of cleavage like stair-stepping patterns. And on the top surface of the mineral here, I do see kind of like a stair-stepping feature, which means that this mineral does likely break along these smooth surfaces. So I know that I definitely have a direct cleavage plane right here, which means that this surface right down here is parallel to it also. So I definitely have one cleavage plane. So what about this one? Same thing. It kind of looks like it stair steps right here. So I have another cleavage plane right here and right here. Again, parallel, so same cleavage plane, same direction. So I know I have one direction of cleavage. I have 2 directions of cleavage. What about this last one? And again, a smooth surface and a smooth surface. So this mineral right here has 3 directions of cleavage. They're at 90 degrees to one another. So now I know that this mineral is non-metallic luster, a hardness of somewhere around 2.5 to 3, and it has 3 directions of cleavage that are at 90 degrees to one another. So what you can do is, in your laboratory manual, you have on Appendix 3.1 and 3.2 these determinative tables, which are essentially flow charts for helping you identify minerals. So once you can identify some of the diagnostic properties like its cleavage or fracture, its hardness, its color, maybe some other diagnostic properties, but the main one being whether or not it has a non-metallic or metallic luster. So at first I'm going to navigate to the page that show the non-metallic luster, which would be not table 1 here. This is all metallic minerals with metallic luster. So it'll be table 2. So table 2, I have 1 page, 2 page, 3 pages of non-metallic luster. So what it breaks it up into first is its hardness. So this one is a hardness less than 2.5. So we know that our mineral is definitely harder than 2.5. So now that brings us to a hardness between 2.5 and 5.5. So it could be any of these minerals or these minerals right here. So the next diagnostic property we could use as the most obvious one is color. So we know our mineral is colorless to white. So it automatically knocks out this one, because this mineral right here, malachite, has a color bright green. Our mineral is not bright green. So now we have narrowed it down to these sets of minerals here. So now we'll look for the color. And so we have 3 that are colorless to white. We have halite, we have barite, and we have fluorite. So now we'll look at the cleavage or fracture. So halite has 3 directions of cleavage at 90 degrees. Barite has 3 directions of cleavage at 90 degrees. And fluorite has 4 directions. So we automatically know it's not fluorite. But now let's take a look at the hardness. We know that our mineral has a hardness of less than 3. So we're left with barite, which has a hardness of 3 to 3.5, and we're left with halite, which is a hardness of 2.5, which means that our mineral that we know that it is colorless to white of non-metallic luster, it has a hardness of somewhere between 2.5 and 3, but definitely less than 3 because we know it's got to be softer than that penny, and it has 3 directions of cleavage at 90 degrees, which means that our mineral in question is halite. So mineral number 18 in your box is halite.